Good day, class. My name is Sudra Kaleton, your facilitator for the course Chemistry of Carbohydrates, Lipids, and Nucleic Acids, Bio 216. Last week, we started on the topic of carbohydrates, and we looked at the properties of carbohydrates, we looked at the functions of carbohydrates, we looked at the classes of carbohydrates, and also that went into the concept of isomerism. Today, we are going to look more into one of the classes of carbohydrates, the monosaccharides. What do we mean by monosaccharides? Monosaccharides, like we defined last time, we're able to say that carbohydrates are polyhydroxy of aldehydes or ketones. So monosaccharides are single polyhydroxy aldehydes or ketone units. And the most abundant monosaccharide in nature is glucose, D, also referred to as dextrose. Monosaccharides are of two families, those containing aldehyde functional groups called aldose, and those with ketone functional groups called ketones. And each of them have their own characteristic structures. So at the end of this class, you should be able to draw the structure of carbohydrates, explain the Fisher and Howard projection of glucose, discuss the cyclicization of Fisher projection formula in monosaccharides. Now, the structure of glucose. When we are looking at the structure of glucose, what we should look at is a straight chain or a cyclic structure. The straight chain is called the Fisher projection, whereas the cyclic structure is called the Howard projection formula of glucose. The straight chain of glucose was devised by a German chemist known as Emil Fischer in 1891, and he's also a winner of the Nobel Prize in Chemistry in 1902. This work on glucose helped him to win that Nobel Prize. In a Fisher projection, the carbohydrate is shown in its open chain form. It's shown in its open chain form. So when you see the carbohydrates, you will see 6 carbon atoms joined together like a chain. Then you have glucose and hydroxide sticking their arms out in a vertical position. Glucose and hydroxide group sticking the arms out in a vertical position. So you know that you are dealing with glucose. Good. You know that they are dealing with the Fisher projection. Sorry, please. So if we want to draw glucose in that Fisher projection, what do we do? Like I said, you have a carbon atom, 6 of them, 1, 2, 3, 4, 5, 6. Then the next step is to attach hydrogen atoms to these carbon atoms. When you do it for glucose, there are 4 atoms of hydrogen on one side and 1 atom of hydrogen on the other side. After doing this, you see you have 1, 2, 3, 4, and then we'll do this. We have 1 there. Well, after doing this, the next step is to attach OH group, which is the hydroxyl group, to these carbon atoms. And you do that, you notice that on the left side, we must make it an HO so that it is the oxygen that is attached to the hydrogen. The oxygen is attached to the hydrogen. Then the final step is to give the glucose its functional group. Give the glucose its functional group. It's attached to table 1, and then you give it a hydrogen bond here. And that's it. Your glucose is ready. So I will find out when we count this glucose, when we count the atoms in this glucose, we'll find out that there are 12 hydrogen atoms, 6 oxygen atoms, and 6 carbon atoms. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you see we have 12 hydrogen atoms, 6 oxygen, 1, 2, 3, 4, 5, 6, and 6 carbon, 1, 2, 3, 4, 5, 6. So that is how we draw our glucose. So I want you to get a piece of paper and look and try it and see whether you can get it. Then the Howard projection is also another way of drawing glucose, but this one draws glucose as a cyclic compound. As a cyclic compound. He is also a chemist, and he also won a Fisher's projection in 1837. To draw the Fisher projection is equally simple. It's just a matter of drawing hexagon and attaching oxygen to it. When you draw a hexagon, what is a hexagon? A 6-sided figure. You attach the oxygen to this connecting point. Then the next step is to add legs for the sides of the hydrogen atom. Don't they look like legs? You add legs to them. You add your AH and H group as they should be. If you have done this, then you have done the hydrogen atom. So let's look at the issue of cyclicization of the Fisher projection formula in monosaccharides. Glucose molecule can exist in linear or cyclic form, but it quickly takes up the ring-like structure when it comes in contact with water. When your marking guide is in the hands, I'm sorry, please. When your glucose is forgive me. First, when glucose is cyclicized, it forms when the oxygen in carbon 1 of glucose reacts with the OH group of carbon 5, it becomes a cyclic structure called a pyranose. You see it becomes a pyranose. The alpha D glucopyranose. Alpha D glucopyranose. How did you get these words? These things that make up this word. Let's start from the pyranose. Pyranose is from the word pyran, a 6-sided figure. The pyran, and then the os means that it is a sugar. So a 6-sided sugar, which is in this case is glucose, glucopyranose. D because we're dealing with D-glucose. Remember, D-glucose has its OH group on the right side. And then alpha, if you remember what we dealt with in our lesson 1 when we talked about the alpha and beta anomers of glucose. Remember we said that when the OH of a carbon atom is facing downwards like this, it is the alpha anomer. And when it's facing upwards like this, it is the beta anomer. So when you have beta D-glucopyranose, it means that this OH group is facing up. This is a D-glucose, and this is a pyranose. It is a pyranose because it's a 6-sided figure that has formed a cyclic. Now remember the O I spoke about in the other slide. Look at it here. This O joins together to form this O here, gives us this. So that's how we get to cyclicize our linear glucose. So when we talk with the ring in pyranose is formed due to the reaction of the hydroxyl group OH on the 5th carbon of sugar with the aldehyde group at carbon 1. Then we also have another form of cyclicization. This one happens when the hydroxyl group reacts with the OH group, the hydroxyl group of carbon 4, reacts with the aldehyde from carbon 1. When this happens, we have something that is called a furanose. This is discussed in further details in your lesson notes. So you can read further about this in your lesson notes. So we have been able to, in this class, draw the structure of glucose, look at both the straight line and the cyclic form of glucose. We have also learned about the Fisher projection formula of glucose and the Howard projection formula of glucose. And then we have been able to see how a straight chain structure of glucose can be cyclicized to form a pyranose or a furanose. So, in conclusion, we say that monosaccharides, e.g. glucose, can structurally exist in straight and cyclic forms. I want to say thank you for listening and have a beautiful day. So, thank you very much for listening. That's the end of the class.